Okay, we're in section 8 of the notes. This is a section on vectors. I realize if you're taking physics at Essex College, they might deal with vectors a little bit different than we're dealing with. But this is, certainly as you move forward in mathematics, this is typically the way vectors are going to be dealt with. All right. So my understanding is that you want to attend lectures, listen to what's being presented to you, try to make sense that it was presented to you, study the notes. We're going to do examples. I say together, I'm going to do examples. You're going to listen. You need to study that examples, and then you can do the supplemental activities in the notes itself. And then after you're done with that, then do the web assign. It's really that simple. All right. So what are we going to do over here? We're going to go to the vector section. All right. So I want to point out in the notes, certainly would love for you to read them. You have a little video over here. I want to point out that a vector is very similar to what you did in Math 19 with vectors. It's either going to be a row of numbers or a column of numbers. And you've done that in Math 119. You had row column matrices. Now we're going to call them vectors. Now in Math 119, they use uppercase letters. We're using these lowercase letters. They're still in bold though, right? Just like in 119, we use bold letters. Now, of course, when I'm at the whiteboard, I can't put a bold letter down. We have a different notation. But I'm going to claim over here is that in 120, at least for vectors, we generally don't use the square brackets. We use this notation over here, all right? Bracket, all right? So the deal about this over here, we're going to talk about magnitude. We'll talk about, addition of vectors, just like you did in 119. You added matrices together. It's the same problem. Scalar multiples of a matrix, same thing you did in 119. We're going to talk about, what I call these vectors over here, I and j. And we're going to say any vector v can be written as a linear combination of I and j. And we'll go through that. We'll talk about the component form of a vector in trigonometric form. We'll go through that. All right, we'll go through that. And again, we're encouraging you to also listen and reread the notes. And then we're going to use the law of cosines to derive a formula for the angle between two vectors, u and v. All right. It involves a computation that pops up a lot, and we define that computation to be a dot product. And we'll go through that. All right. We have a nice little formula for it. Then we get to the examples. All right, I'm going to switch over to the whiteboard. Just give me a second to do so. And we're at the whiteboard. All right. So as I'm doing this whiteboard business, just want to emphasize we're in this section on the vectors. And then I'm going to, talk about it. And so the way I'm talking about this over here is, I'm going to talk about what you did in Math 119. So in 119, you had this, this matrix notation. All right. And the matrix notation, you had rows and columns. Now, if you look at this letter V in Math 119, we just use uppercase letters for the matrices. Now we're using lowercase letters, and certainly V is reminiscent of vector. Now, when I write the letter V down, I can't really distinguish this from bold. It would take me too much effort. So we typically put a line above it that looks like sort of like an arrow. So I'm going to say, this is a matrix, all right? But it's either going to be a row or column. And at this level of the game, it's going to be a row vector with only two elements in it. All right, so if we look at the vector V over here, it's a matrix where row 1 is -7 and 15, right? So it has one row, right? Two columns, all right? But I'll be honest with you, for the most part, we don't use that matrix notation. We use this bracket notation, all right? And then we put the listing of numbers down over here. Well, it's only two numbers, -7. But here's the deal. In 119, they didn't use the comma. We're going to use a comma now, all right? So -7, 15. I want to visualize the vector for you. And as we do that, I'm going to put an XY axis down for you. All right. Now, if I were looking at that vector V, I want to visualize it. And I'm going to say it's something to do with a point. And what's the point going to be? Well, the point, it's going to be in center position, by the way. It's -7, 15. So I'm going to say, if I thought about that, -7, the abscissa is over here somewhere, and 15 is way up there. All right, I'll put that point down for you. All right, I'm going to say that's a point, -7, 15. That's a point, different notation. And this is in center position. This point would be 0, 0. I'm going to draw my vector in now. What's the vector look like? It looks like this. Okay, so I'm going to say this point over here is the initial point. And this guy over here is terminal point. And we like our vectors in standard position, all right? So it's important you know we're in standard position over here. So I got a claim over here. If someone said something about, what's the angle, right? This would be the angle theta for that vector. Standard position, by the way. And if someone said, what's the length of that vector, right? What's the length of the vector? We could do it. And how do we do it? What you've learned in math, the beginning of the semester with the Pythagorean theorem, all right? So let's go through the next thing up. We got a little vector notation down over there. And now we're going to talk about magnitude, all right? Just like I said before. So I'm going to draw another picture and push this on the side. And the other picture is going to look like this. And I'm going to call the axis something different now. I'm going to call it V1, V2. I'm going to put a vector in now. The initial point is 0, 0. The terminal point is an ordered pair of numbers, V1, comma, V2. Right, this is the vector V. I'm hoping you can see the difference between my V1, V2, and then the vector V, which has the bar above it. So what's the vector V going to be? The vector V is going to be V1, comma, V2. It's got that bracket notation on it. Now, one of the questions they're going to ask about is they're going to ask about the angle, theta, and they're going to ask about the length of the vector V, the length. Of vector V. The length of the vector V is also called the magnitude. And we have notation for that. And the notation for that, again, I want to point out in the notes, I give you a much better looking notation because I typeset it, but it's a double bar. And this is read as the length of the vector V or the magnitude. Well, I think I know about that. And how do I know about that? From the beginning of the semester. And what's that going to be? Well, we've done this before. I want to point out it's the radius, really. So it's just the radius of this over here. And what's r squared going to be? Well, it's going to be V1 squared plus V2 squared. So what's the length of it? It's really just r. And that's going to be a positive number. It's going to be the square root. Let's write that down for you. Let's go over here. I want to point out where it is in your notes. Right there. The magnitude of vector V is given by. All right, I want to point out number 2 and number 3 are important, but it is identical to what you did in math 119 with matrices. There's no difference. All right, let's go through this. The addition of vectors couldn't be easier. U plus V, just add their components together, just like you did in math 119 when you add matrices together. What's scalar multiplication? It's basically resizing it. It's making them longer or shorter, possibly also shrinking it to 0, by the way. What are you doing? Just like you did in 119. Just like you did in 119. All right, what'd you do in 119? K is a scalar, it's some real number. You multiply each component of the vector or the matrix by K, just like you did in math 119. All right, let's talk about 2 special matrices. And those 2 special matrices are called I and J. All right, so let me just say there's 2 of them over here. Okay, and what do they say about these? They say any vector V with components V1, V2 can be written as a linear combination of I and J as follows. So they say vector V can be written as V1 times A plus V2 times J. Let me write that down for you though. All right, let's see if I can understand what you're saying. So V1, that's a scalar. And what's I? It's 1, 0 plus V2 times J. And what's J? And these are multiplications. J is 0, 1. Well, if you did that, what would you get? You would get, it's a scalar multiple, V1, 0, that's V, plus 0, V2. If you add those together, I'm hoping you'd realize what you get is this over here. All right? So I'm going to say for the most part, I actually prefer not to use I and J at this level. However, it is written down all over the place, upper level vectors where you have IJ. All right, let's go to component form with the trigonometric. All right, so I'm going to go over here, back to this picture over here. And I'm going to talk about, the defining features of this thing over here. And as I do that, again, we're not trying to confuse you over here. We're looking back to trigonometry. And that blue line over there is like the radius of a circle. And the length of that blue line is just this business over here. That's the radius of a circle. So what do I got over here? I'm going to write it down for you. I'm going to write down the definitions I know about though. So the cosine of theta, what's that going to be? Well, looking at my picture, it's going to be the abscissa, which is V1, over the length of the radius, which we now know to be the magnitude of the vector V. And the sine of theta is going to be the ordinate, which is V2, over the radius, which is the length of the vector V. So now I know that V1 can be written as the length of the vector V times the cosine of theta. And V2 can be written as the length of the vector V times the sine of theta. All right, let me show you where this is in the notes. And I'll post this over. And we just did that right here. Okay, that's an important fact. All right. Again, I realize this might be overwhelming and say where it's going. It's going to vector, the vectors that we're covering this section. We're not going to go much beyond what we just mentioned here up here. So from here, we're going to develop another simple formula. And the simple formula is going to be, you're going to be given two non-zero vectors, right? Our objective, though, is to figure out the angle between those two vectors. And we're going to use the law of cosines to do it. All right. This will be fully explained on the following page. Let's go to the next page. Right. Again, I know this is difficult. My claim over here is for some students, they just say, it's so difficult, I don't care what the results are, just tell me the result. There's nothing wrong with that. All right. My claim over here, though, is it would be nice if you could reason through it. All right. And I'm going to go through that with you. I'm going to put my picture down. Whoops, let me do that. Standard position, a vector. This vector over here, the point, I'm going to say V1, V2. This is the vector V. The vector V is V1, V2. All right. Let me do the next guy. I'll put him over here. All right, it's another vector. I'm going to call out the vector U. So this is going to be U1, U2. That's the vector u, bracket u1, u2. Now someone says, what do you want to get? I want to get the angle between those vectors. I'm going to call that theta. All right, I'm going to call it theta. All right, let's take a look. And what's the length of this side over here, the blue one? Let's write that down for you. This guy's length is a length of v. And what's this other guy's length? It's a length of u. All right. Now, granted, the law of cosine is relatively new to you. I'm going to put another side in here, don't I? I'll just kind of just dot it in. There's a point there. All right, there's a side there. I hope you could agree with that. We'll talk about that a little bit later. All right. And let's take a look. So let's write that down, law of cosines. So let's go back over here. And I want to talk about this side over here. And again, I want to just look at what's written over here, and I'll go through that with you. All right. But I'm going to say that there's some side over there. All right. So I'm just going to put a question mark there and square it, law of cosines. Let's write this down. So it's going to be, side u squared. Put this over here. We'll do that later. Plus side v squared. Again, we'll do that later. Minus 2. I gotta push that over. It's getting kind of complicated, right? V cosine of theta. Looks like a nightmare, doesn't it? Question is, what's that question mark over there? Well, I want to point out, one thing nice about vectors is I could call this the initial point and this the terminal point, but I have to move it back towards the origin. And that should be very easy to do, by the way, right, to move that. And someone says, could you move it with your fingers? We could. We got a better way of doing it. So I'm going to say over here, this vector here, it's a vector now, is going to be, I'm going to look what I did over there. Okay, I'm going to do the other direction because I want to keep the same notes. Let me go backwards a little bit. To get this vector over here, I'm just going to say it's upper minus lower. Right? It's like moving it around. That's all we're doing. So this vector over here, I'll just call it a new vector. It's going to be bracket. Let's write this down. U1 minus V1, comma, U2 minus V2. All right. Let me go back over here and point it out to you in the notes. And what do I want? The length of U minus V. So I'm going to point over here is I want the length of this thing over here. And I'll write that down. A little different notation though. The length of that vector. Let's write the vector down. Now, of course, this is where all hell breaking loose, but I still have to go through it. I would say this, though. I wouldn't go through this if this didn't lead anywhere. All right, let's write that one down at a time. Now, by the way, you would have to know, and I'll write this over here, that the length of U is equal to the square root of U1 squared plus U2 squared. Whoops, sorry about that. Well, let me write that down then. This would be U1 squared plus U2 squared. And why is that? I'm squaring it. Then what do you get over here? Plus, well, this would be V1 squared plus V2 squared. I'll point out what I just did. I did this, I did this. Let's keep going. I know it's tough. Gonna get my pen going again. Minus 2 length of u times the length of v, put little dots there for you, times the cosine of theta. I gotta be honest with you, the other side's a little complicated to me. I'm gonna write it down for you. And what would that be? I'm looking at it, and it's just basically the component squared. And I'll put this down for you. u1 minus v1 squared plus u2 minus v2 squared. Again, if this doesn't lead anywhere, it would be kind of pointless, but I think it's going to lead somewhere. Let's write this down. u1 squared minus 2 u1 v1 plus v1 squared. I want to point out what we just did. We just did this part over here. Let's keep going. An alphabet soup at this point. Then I'd get u2 squared minus 2u2 v2 plus v2 squared. And this could go on for a long ways. Let's keep going. u1 squared plus u2 squared plus v1 squared plus v2 squared minus 2 length of u. Boy, this could really go on for days, couldn't it? Length of v, cosine theta. All right, let's take a look. I'm going to kind of look at it. It looks terrible, it really does. But I mean, I could subtract this from both sides. I could subtract this from both sides. And I'm glad things are disappearing because it was a nightmare before. I could subtract this from both sides, and I could subtract this from both sides. Where is it? Over there. Let's write down what we get. Right, I'm going to write this down for you. So you get minus 2 u1 v1 minus 2 u2 v2 is equal to minus 2 length of u, length of v, cosine of theta. I'm going to divide both sides by minus 2. Let's write that down now. u1 v1 plus u2 v2 is the length of u times the length of v times the cosine of theta. All right, let's keep going. Now what I'm going to do is I'm going to divide both sides by the length of u and the length of v. Now, of course, these vectors have to be non-zero at this point. Otherwise, I couldn't divide through. What do you get over here? We get u1 v1 plus u2 v2, the length of u times the length of v equals the cosine of theta. I want to point out that's a really nice formula. It's really compact. And what does it give me? It says the cosine of theta is going to be that. Here's another product that I'm looking at. I should say another result we're looking at. This guy up here pops up so much in mathematics that they gave it a name. And I'll tell you what the name is. U dot V is that result, which is U1 V1 plus U2 V2. Let's write that down now. So this formula becomes U, vector U, dot vector V. That's how it's defined. This is called a dot product. By the way, if something pops up a lot, you give it a name. Over the length of U times the length of V is the cosine of theta. This form is really important over here. Let me go back to the notes. I want to point out where this stuff is written down for you. And that result, I know is very difficult to get through that. We defined the dot product. I'll tell you where that is. And we defined this thing over here. I derived it, sorry. We derived that. We defined a dot product and we derived it. All right, we'll go to examples next. I realize it's tough. It's vectors. All right, we'll get through it. Thank you.